Welcome to the Central High School Booster Club Learning Task. In this task, it will be very important for you to pay attention to the information given to you throughout this task in paragraph form. You'll be taking that information to create matrices. Once your matrices are created, you'll then be performing a variety of different operations on those matrices. You're going to be adding matrices, subtracting matrices, multiplying matrices by a multiplier. We call that scalar multiplication. And then you'll be multiplying two matrices like this matrix times the other. I'll be sure to go over some specifics throughout this task and to give you a little bit of insight as to how to identify matrices by dimension and then how to multiply matrices. So let's begin. Again, I did say it was important to pay attention to the information in these tasks. Of course, you like the teddy bear, the t-shirt, and the bag. I like the teddy bear. But let's first talk about A here on the top of the second page. Notice A has a letter that would identify the matrix as matrix A, but then the first row, these numbers across, are the wholesale prices for bears, totes, and t-shirts. Now again, this comes from this paragraph here. I could select it, or I could draw around it, but this paragraph, the second paragraph, gives you the information for matrix A. Now the second row of numbers are your decorations. The decorations being $1.25 for the bear, 90 cents for the tote, t-shirts being $1.05. And that's pretty much it when you want to identify or create your matrices, as you'll be expected to do in, I believe, 2 through 5. Just want to pay a little homage to this little image here. Notice matrix A, A11. Well, this refers to row 1 and the value 1, or the column 1. Let me actually write column 1. Alright, so A11 is row 1, column 1. You can still be on row 1, but be in column 2 or column 3. So that's 11 for column 1 in row 1, 12 for column 2 in row 1, and 13 for column 3 in row 1. When you drop down, this will be row 2, 21, 22, 23, and so on. But that's how you identify the individual numbers in your matrices. But let's also talk about how you find the dimensions of your matrix. Your dimensions are always row by column, and you'll see them inside of brackets. Now in this case, A is 2 rows, so it's a 2 by 3. Okay. Now number 1 says write and label, your matrices, and in 2, 3, 4, and 5 to give you kind of specifics or what to look for when wanting to or when trying to label your matrices. But then let's also scroll down to number 6. In number 6, this question makes reference to what we refer to as the square matrices. And with a square matrix, it's just like, I can't say just like, it's kind of like in what you learned about geometry or the square, where the square has all sides that are the same. Well, with matrices, if the rows and columns are the same, we refer to it as a square matrix. So a 1 by 1 would be a square matrix, a 2 by 2 would be a square matrix, a 3 by 3, a 4 by 4, a 5 by 5, and so on. But then let's move on down. Move on down the road. I guess I need to stay at teaching. Anyway, number 7. They ask you a question that pertains to this paragraph, several local companies, and so on and so on. Hopefully you'll be able to answer that question based off the information that was given. Now number 8, I want you to make sure that you create a 1 by 3. So for instance, 1 would be the number of rows, and it's going to have 3 numbers going across that would fit on these spaces. So that's your first number, your second number, and your third. All right, that's a 1 by 3 matrix. Now let's talk about it talks about use this new matrix G and matrix E from number 5 to find matrix P, the profit. So how would you find profit? Well, I know that in order to get profit, say something cost me 10 bucks and I end up selling it for 50. In order to get the profit, I would take this number and subtract that one. So obviously you are going to be expected to subtract two matrices. And as long as you have matrices that are like, say, a 2 by 2, that needs to be a 2, minus a 2 by 2, you can certainly subtract. I'll be sure I'll show you what the subtraction looks like later. Now, down here, I start to show you what scalar multiplication is. And I'm pretty sure you don't know what that is, so let me just explain it to you. Scalar multiplication is multiplying one number times every number inside of a matrix. So notice this 1 over 6 has a B next to it. Well, that means 1 over 6 times matrix B. Or 1 over 6 times the 15, the 10, the 5, the 20, the 50, you know, every other number in the matrix. And at the end of the day, you're going to get fractions. Now, some of you might say, oh, I have a calculator, I don't get fractions, it gives me decimals. Well, those decimals are the fractions. Or you could say the fractions are the decimals. The only hiccup you're going to run into is, say for instance with 1/6 or 1/3. Those are irrational fractions, meaning that, for instance, with 1/3, you don't want to write just 0.3 because that 3 repeats. Even 0.33 would be inaccurate. But again, your teacher might be okay with you giving those decimal values as long as you show at least 4 or 5 or 6 of them. But for my students at my school, yeah, they need to give me some fractions. Now let's talk about multiplication. But right before we do some multiplying, I want to tell you what the subtraction looked like. I did make reference to telling you, hey, I'm going to tell you about it later. Anyway, can we subtract L minus T? With adding and subtracting, as long as the dimensions are the same, you can move forward. So you have 1, and then that's the first number in the first row. Do we have a number in the first number? I'm sorry, we do. What's the first number in the first row here? So we're going to end up saying, for instance, if we did L minus T, we would do 1 minus 1, which is 0. The second number in the first row, 3 minus 0 is 3. The first number in the second row, negative 5 minus 0 is negative 5. And the 4 minus 1 gives you 3. So we subtracted a 2 by 2 and we get a 2 by 2. That's how it's supposed to work. Now, as we move forward to adding in, let's talk about adding. Adding is the same as subtracting. As long as the dimensions are the same, you can move forward. But with multiplication, you have to have some specifics in place, particularly your inner numbers, to do anything. So we're going to talk about A. It says L times M. L is a 2 by 2. M is a 2 by 4. So, is the multiplication possible? Well, we have 2 by 2 and a 2 by 4. I did tell you that as long as the inner numbers are the same, you can move forward multiplying. Are the inner numbers the same? Yes. So that means our answer would be a 2 by 4 matrix. Now some people might say, well, where did you get the 4 or the 2? I'll tell you. Give me a second. Da, 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 da. All right. So as long as the inner numbers are the same, the 2 and the 2, your outer numbers, which is this 2 and that 4, would create your answers. So for instance, if we had a 3 by 6, and a 6 by 2, I click the button that I don't like clicking, and it's going to mess me up for a little bit, and I'm good. So we had a 3 by 6 and a 6 by 2. Are your inner numbers the same? Some people say inside. Yes. So this is going to end up being a 3 by 2 matrix. But if you had a 5 by 1 and a 1 by 4, pretend I had the brackets on there. No, I meant to, let's say a 4 by 4. Again, pretend the brackets are on there. So are the inner numbers the same? No. Can you multiply? No. All right. Now I am going to show you how to do one problem using multiplication. I certainly did provide some videos for you so that you can either play this one over and over again or the ones on YouTube. So say we had 3, 6, 2, 1, and then we have 5 and a 4. First, is the multiplication possible? You have a 2 by 2 and you have a 2 by 1. Yes, your answer is going to be a 2 by 1. So let's see what goes there. Now, because of what I'm working with, I need to go ahead and just leave that blank for right now. Anyway, in order to multiply, you want to multiply across and then down. I like how I wrote that out because that's exactly what you need to do. You're going to end up multiplying the 3 times the 5 and adding that to the 6 times the 4. Then you're going to take the 2 times the 5 and the 1 plus the 4. I'm sorry, the 1 times the 4. The 3 times the 5 is 15. The 6 plus the 4, I'm sorry, the 6 times the 4 is 24. You're going to get 39 over 2 times 5 is 10. 1 times 4 is 4 over 14. We multiply across 3 times 5, 6 times 4, and then 2 times 5, 1 times 4. We multiplied across and down. If you have any questions, please be sure to ask your online teacher.